Question 7 is a farmer problem again, but this is a little bit different because the farmer is going to put the pen up against a river. And it looks like he or she is not dividing this up, but he's leaving a little room for the animal to take a sip of water or go for a swim or something. So here's our sketch of the situation. Now, what we can control, in other words, our independent variables, is how we're going to use up this 4,000. So what I'm going to say is we can definitely draw a rectangle like this, or we could draw a rectangle that looks like this. So I'm going to let x be, and I'm going to write out specifically, x is going to represent the number of meters. X is a number. It's the number of meters in the side that's perpendicular to the river. And for the moment, I'm going to say the other side, one that's parallel to the river, we will call y. And what we're trying to do here is, let's see, the phrase is largest area. So we're trying to maximize the area. And again, this is a rectangle. So the area is x times y. Okay, good enough. And if you have two independent variables in your objective function, which we do, you have some work to do. We do have some work to do. What else do you know? Well, we haven't even touched that 4,000. So we know that 2x plus y, the amount that we're using, is 4,000. So I can write y is 4,000 minus 2x, and then the objective function we can write as x times 4,000 minus 2x. And when they ask for the domain, well, here's what I'm going to say. X could be as long as we want. We know that y can't be 0. We know x can't be 0. So if y was 0, that would mean that x would have to be 2,000. So let's take any x value between 0 and 2,000. And that's kind of handy because now we need to sketch a graph of the objective function. And again, we're looking at area as a function of x, and we have a quadratic that, in fact, is already factored for us. So if we go to look for the x-intercepts, we're going to use the zero product property. So x is 0 or x is 2,000. And once again, we have those very handy x-intercepts, and the axis of symmetry is going to be smack down the middle. So we know that our vertex on the axis of symmetry will have an x value exactly halfway between, so at 1,000. And the other thing we know is that if I plug 1,000 into this objective function, that's 1,000 times, well, I'm going to have 4,000 minus 2,000, so that's 2,000. And that is 2 with 6 zeros, so 2 million. Okay, ooh, and so this is x, so this is meters in side perpendicular to the river. And this is square meters area of the pen. So let's see, we were trying to maximize the area. Let's say the maximum area can be achieved when 1,000 meters are used for the sides perpendicular to the river, and i.e. the dimensions are 1,000 meters by, well, we know y is going to be 2,000. 2,000 meters, yielding a maximum area of 2 million square meters.